All right, so here's our second day of antiderivatives. We're going to do two of the harder ones, okay? But we're going to start off with trying to figure out how to approach this one before I give you the rule and kind of a different way that we're going to do it. So every time I start, I end up putting stuff down with my arm. All right, 7-4. Okay, we're going to look at the antiderivative of 3x plus 5 to the 7th. Okay, so this was a chain rule when we took the derivative. So now we're going to look towards doing the opposite. So the first thing we're going to look at is we're going to check if we use the x to the n rule, which is x to the n plus 1 over n plus 1. We're going to use that rule to see if it works. Okay, so what would happen on this one? We would get 3x plus 5. We're going to increase by 8. And then instead of putting it over 8, we're going to move it out front. Plus c. So we're going to see if this rule works for this particular antiderivative by checking it by taking the derivative. So we're going to do d dx of 1/8 3x plus 5 to the 8th. Okay, so in order to do the chain rule to solve this, we're going to bring the 8 down times 1/8 3x plus 5 to the 7th times the derivative of the inside, which is 3. So these cross off, but I'm left with this extra 3 that I didn't have anything to counteract with it. So my answer ends up being 3x plus 5 to the 7th, which is not what I wanted. So I need to counteract that. So my correct antiderivative is going to take 1/3 times 1/8 3x plus 5 to the 8th plus c. Okay, which does simplify to 1/24 3x plus 5 to the 8th plus c. Okay, you can take the big parentheses and put it over 24. That's totally fine. Okay, so the book does give us two rules that you are welcome to use. So if you know how to use them or you want to work on learning to use them, you're more than welcome to use them. So the first one works for the one that we just did. Ax plus b to the n dx is going to give you 1/a. So you're going to get the counteract the derivative on the inside times 1/n plus 1 ax plus b n plus 1 plus c. Okay, but be very careful because this 1/a often gets confused because it's not always just an a. So I'm not going to go through that, but if you want to use that rule, you are welcome to use that rule. Okay, e to the ax plus b, that's the other one. We don't have to counteract the natural log rule that we did when we did the chain rule. Okay, so again, this one is going to counteract with that 1/a. Again, it's not just a number always. Okay, and then the e ax plus b stays the same, plus c. All right, now what this section really wants you to do is use what is called U substitution. And when you do the web work problems, it's going to ask in the first blank for U equals and then it's going to ask for the antiderivative. Okay, so it's going to have two pieces. So we're going to work on showing you how to do U substitution for the same problem we just did. And it works for both types. Okay, so the U here is actually 3x plus 5, whatever's in that parentheses. So I always write to the right side, U equals 3x plus 5. And then we're going to take the derivative. We're going to take this and take the derivative. So we get du equals 3 dx. And then we're going to solve for dx so that we can plug it in for dx. So we get 1/3 du equals dx. So this is what we're going to substitute in here in a second. All right. The other thing we're substituting in is u. We just said u equals 3x plus 5. So we're going to substitute u in as well. So we still have the integral. We're going to get u to the 7th, 1/3 du. So here's this piece that got substituted in, and here's the u. Okay. The integral is only used when there's a dx or a du. All right. Once we do the next step, then we're done. And the reason why we do this is because it is really easy to take the antiderivative of u to the 7th. So we get u to the 8th over 8 times 1/3 plus c. Okay, last step besides simplifying the 8 and the 3 is to substitute 3x plus 5 back in for u. So I get 3x plus 5 to the 8th over 24 plus c. And if we look back at the last whiteboard, we will see that I got the same answer right here. So I get the same thing either way. But you'll see that if we do the same thing with this u substitution piece right here, that it just becomes easier to do the same pattern. So let's do another one that's just like that one. So we're going to do 2x cubed plus 11 to the 7th x squared dx. Okay, so again, the u is the inside. So u equals 2x cubed plus 11. So that's what goes in when you put it into web work. So u equals 2x cubed plus 11. And then you're going to take the derivative for du. So the derivative is 6x squared dx. And when we solve for dx, whatever this is ends up going underneath 1 every time. So if you notice that, it gets pretty easy. So I get 1 over 6x squared du equals dx. So this whole piece is going to get substituted in. All right, so I'm going to get u to the 7th. Again, the only piece that gets taken out is this piece here. I still have this x squared, but I have this big piece that gets added in. 1 over 6x squared du. So notice here, I have this x squared and this x squared on the bottom that are now going to cancel out. That's what I wanted because I only have a u here. I can only differentiate u. I can't differentiate x because I have the du. Okay, so let's do the antiderivative. I'm going to write one extra line for those who need to see. I'm left with u to the 7th, 1/6 du. No need to write it. I just wrote it for those that need to see it a little bit more clearly. So I get 1/6 u to the 8th over 8 plus c. And then again, I'm going to plug u back in. Here's my u. Plug it back in. 2x cubed plus 11 to the 8th over 48 plus c. Okay, so those are the ones that have the parentheses to the power. All right, the other ones we're going to see again are, we're going to have definite integrals and we're going to have e integrals. Okay, so the u here is the whole exponent. So u equals 2x plus 5. So when I work this for the problem, I'm gonna, again, take the derivative. Du equals 2 dx. Solve for dx. I get 1/2 du equals dx. Okay, so now I'm going to plug it back in. So again, the u is only the exponent. So 1 to 3 eu. Substitute this in for dx. 1/2 du. Now I can take the antiderivative. 1/2 eu. Perfect, really easy, from 1 to 3. So I'm going to substitute this back in. 1/2 e to the 2x plus 5 from 1 to 3. Okay, so if I'm going to plug 3 in, I get 1/2 e 2 times 3 plus 5 minus 1/2 e 2 times 1 plus 5. So I'm going to get 1/2 e, 3 plus 5 is 8. Oops, I kind of did these backwards. So hold on, let's erase this. I did this one wrong. I wrote it wrong. It happens. This is 2 times 3 plus 5. So 2 times 3 is 6 plus 5 is 11. Minus 1/2 e. 2 times 1 is 2 plus 5 is 7. Okay, so I typed this big mess into the calculator rather than getting 2, and I got a very large number, 29,388, and I rounded to 2 decimal places, 0.75. Okay, so we're going to do one more. With e. This one goes from -2 to 1. And I get x e to the x squared dx. So yes, we can have an exponent to an exponent. It does happen occasionally. Again, u is equal to the exponent. Okay. So remember, I'm going to take the derivative to get du, and I get 2x dx. I'm gonna solve for dx, so I get 1 over 2x du equals dx. Again, it's the same pattern over and over, but you have to do it enough times to know what you're doing. If you don't, then you're really going to get lost. Okay, so u is going to go in place of the exponent. Okay, so I'm going to copy x down, e to the u, and then this goes in for dx. 1 over 2x du. Remember, I can only differentiate for u. So I must have these x's drop off, which they do. So if I did the differentiation correctly, then the x's drop off. So I'm going to get 1/2 e to the u from -2 to 1, 1/2 e to the x squared from -2 to 1. So when I plug this in, I get 1/2 e to the 1 squared minus 1/2 e to the -2 squared. Make sure that you still do it in order because it's easy to do this one backwards. So I get 1/2 e to the first minus 1/2 e to the +4. And when I type that into the calculator, I get a -25.94. Okay? So make sure if you get confused with this, work through the problems very carefully with your classwork group. This is an easy lesson where students either get it or don't get it. When you do the web work on this one, it definitely wants you to put in the +c's. So definitely put those +c's in for this one.